Okay, cool. Let's get started. Okay, so I brought up this diagram a couple weeks ago, right when we passed like HTML and CSS. I know that might seem like a while ago, but we've actually covered a lot of material. By now, you guys know HTML, CSS, JavaScript, some front-end languages like React, libraries, and we got into backend a little bit, and now we're going to be kind of finishing the rudimentary or like the basic knowledge of backend today. And believe it or not, after today, you guys are essentially going to have all the tools learned to build a full stack website. So that's pretty exciting. You might be thinking like, I don't really know how to do anything yet, which is how I felt around this time last semester when I was taking the decal. But starting Thursday, we're actually going to be doing final project introductions. So you guys are going to like get with your teams, be assigned groups, or like join a group based on like if you have other friends in the class, be assigned mentors, and then work on a full website. So do everything from like bottom to the top. I mean, you can really think of anything you guys want to do, any website you guys have thought of, any ideas, you can start thinking about them now. And on Thursday, we're going to get together and actually start the final project process. And then we're going to have presentations and basically like a little over a month from now. So yeah, after this lecture, you guys are going to be full stack developers, and then you're going to get into your groups and actually start working on stuff, which is like pretty exciting considering we only started doing this a couple weeks ago. But anyway, today's lesson is about Express and MongoDB. And as a recap of the last lecture, which was the intro to backend, we talked about HTTP, REST, and Postman. So again, we use HTTP requests or hypertext transfer protocol requests to communicate with servers. HTTP responses are sent back by a server to the client. So a client makes a request to the server then responds to the client with some message or some data, basically passed through a JSON object, which we can then read and understand and interpolate. And then REST, we talked about, is an architectural style of building APIs. So when you guys are building your APIs and kind of organizing your servers, what to look out for, what to think about when you're designing your APIs. And then we looked at Postman to create mock HTTP requests and view responses from APIs. So we were basically tapping into like endpoints from some APIs, getting some data, and we were actually creating our own API and testing it out using Postman. So all very exciting stuff. Here's a diagram of what this whole process looks like. So I talked about it a bit last time, but I think this is like kind of a good summary of everything I talked about. So you have your computer, which is in the browser. You make a request via the internet to some API. And the API kind of acts as like a middleman between your client and the server. So an API stands for Application Programmable Interface. So it's basically just an interface that allows you, the client, to interact with the endpoint, the server. So the API is something that is built in the middle to allow the client and the server to interact with each other. So let's say we make some requests to the server. The server can then interact with the database or store something in the database or pull something from the database, which is essentially the last point of this whole backend cycle that we're going to talk about today. And then, of course, after the server does what it wants, we program something into the API to return something. So then via the internet, a response will come back to the client, which is also something we talked about last lecture, and which we're going to like really emphasize this lecture. And you guys are gonna be able to see like if you were at all confused about any like APIs or like what it is or like what backend really means, we're going to get to all your questions in this lecture. But first, let's talk about Express. So Express.js is a backend web application framework for Node.js. And it's essentially designed for building web applications and APIs. So we touched a little bit on it last lecture. If you guys remember, we imported Express, and I told you guys we import Express by saying require. And the Express library is essentially just a framework that helps you create backend applications, write APIs, connect with servers, and it has a whole bunch of useful like built-in libraries and tools that we use from the Express library to go ahead and build APIs and work in the backend. So this is kind of an example of what we did last time. we imported Express, we initialized some application, and then we set some endpoint as this /, which is essentially just like the home page. It's like the default route, which we're going to get when we like go to some website. We are creating a callback function, which is called back once the HTTP request, the GET request is fulfilled. And then we're sending back to our client response that's saying, hi, your requests have been received. And then we're also listening on ports. I talked a little bit about ports last time. It's essentially just a place that your server is located. So if we're listening on port 2000, then we're going to say that our application is listening. We're just going to tell the client when they like start our server that we're going to be listening at this localhost address, basically. So yeah, let's talk a little bit about databases. It's something I got to at the end of last lecture. I pointed out a little bit. So we created like an API, and we created a way to communicate with our servers. But the problem was we couldn't store anything. You know, the server like had no functionality to like really persist throughout new application cycles. So like, let's say like we want to create some kind of like to-do list, right? And we want to say, you know, I have some homework assignment due, I have some project due, whatever. You're trying to create a to-do list, but the problem is your server can only receive information and send it back. It has no way to actually store that information. So what we're going to be doing today is, even if you're killing your server, essentially like shutting it down and then rebooting it, we're giving the server a way to actually store data in a database. So when we decide to like add something to our database or get something from our database, it actually persists throughout however long we want it to be there for, and constantly add and remove and update things in our database to kind of store kind of like a working flow within our application. Okay, so what are databases? They're organized collections of structured information or data typically stored electronically in a computer system. So what does this mean? It's basically just organized pieces of data in some kind of data structure. There are two different types of databases. There's SQL databases and there's NoSQL databases. So SQL databases is what you kind of like generically think of when you think of databases, right? Like you know, SQL, a lot of you guys have like taken 61A, you guys have done, you know, SQL like joins and all that stuff. So that's basically relational databases. So there's a bunch out there like Oracle, MySQL, Microsoft SQL Server, and Postgre SQL. And then there's NoSQL databases, which are basically like more flexible models that actually don't use SQL, which is why they're called NoSQL databases. They're non-relational, and they basically are just flexible and really efficient, and honestly way more easier to use than SQL databases, which is why they're so popular. And for example, there's like MongoDB and DynamoDB, which are really popular ones. But the one that we're going to be focused on, and the one that's like really common in the industry today, and the one that I'm going to teach you today, is MongoDB. So again, just as a visual image before we dive into everything, we have our client, we talk with our server through some API, and the server can actually communicate with a database to store and retrieve information and send it back to our user. And so we're going to talk about our first basically database library, which is MongoDB. So MongoDB is a NoSQL database that's really easy to use and interact with. It's super popular, and I'm going to teach you guys how to do it today. And we're going to get into a demo. So literally the rest of this lecture is just this demo. It's like pretty long, and it's going to teach you guys a lot, and it's going to be super interesting. So I would really encourage you guys to follow along, because I'm going to go through it pretty slowly. And if you have any questions, you can let me know. But we're going to dive into the code right now and just go step by step into building an API, creating a database, storing things in a database, getting things from the database, updating our database, and deleting things from the database. So we're going to do a bunch of stuff. And by the end of this, you guys are going to be pros at everything related to backend. So let's open VS Code. And I have a completely blank file, and I'm going to call it server.js, and I'm going to save it in test lecture 11. Okay. And also open up a terminal in your VS Code by just going to terminal, new terminal, or if you already have one open, you can just say view terminal. And we're going to type in a command from last time just to make sure that y'all have Express already in there. But let me .js. Okay. Run this command in your terminal. And this essentially is the same thing we did last time. We're just installing Express. The way we do --save is that basically saying that like we're going to install Express for like future applications to come. So if you don't do --save, it'll basically you have to run it every single time you start a new project. If you do --save, you're going to like always have it. So I'm going to run it again. It's going to take a second. So I'll give you guys like a minute. Cool. Okay, so we're gonna go line by line. This is like an application I created a couple days ago. So let's get started. So let's import Express, and the way we do that is we say const express equals require Express. This is just importing Express. We did this last time. And then let's define a port that we're going to use on our local host. So we're going to say process.env.port for 3000, which is basically saying we're kind of gonna set our default port to 3000, which is like pretty common. There's like 3000, 3001, 3002, 8000. They're all really common ports. I can't tell you why. That's just like industry standard stuff. And then we're going to initialize some app, some Express app. And we're going to do one thing today that I'm going to introduce, something called a router. So I talked about React routers a bit in the advanced React lecture. And I'm going to introduce backend routers today, which is something that's really useful. And I'll explain it in a little bit. But let's just call our router. And then we're going to initialize it by tapping into the Express library and saying we want to return some kind of router. And then we need two utility functions. So basically, you guys can copy this code here, which is, there are two utility functions which we're going to be using. So app.use is saying that we kind of like an import, but for our app that we initialized. And we're saying that we need express.json is a utility for request bodies. So if you guys remember last time, inside of like HTTP requests, we're saying like, you know, request.body.something. It's basically saying we need to get the information that was passed into the request. And the second import is saying that we need utility for query parameters. So it's essentially the same idea where we need to set up, it's just useful utilities that we're going to use when we're like getting and receiving HTTP requests. Okay, and then we're going to set up our server. So we're going to tell our app that we want to use this router. So just follow this along for now, and then I'll explain it in a second. And then we're going to say that we want our application to listen on some port. We're going to create a callback function that's saying once our application is listening on some port, we're going to say that we want a console.log that our app is listening at, and it'll be localhost 3000 because we set it to 3000, but okay. Actually, let's just copy this. We're using like the backticker here, which if you guys remember is basically a way of just, which is basically just a way of, the backticker is so we can use this like $sign where you can like put a variable inside instead of saying like plus, just like candy syntax. So what's going to happen here is that when we run our server, it's going to say that we're going to be running this server at localhost, whatever we define our port to be, and our port is up here, and it's probably going to go to port 3000. I can hard code it and just say I want it on port 3000, but this is like I think this is saying like if essentially if a port's already open, run it on that port. If not, just run it on 3000. Okay. Okay, cool. So let's get into, find the folder where you stored your server.js file. For me, it was in lecture 11. So you have my server, and then I'm going to run server.js. Cool. And if I run it, y'all can see that I have example app listening at some localhost. I'm going to copy that address and open up Postman, which we did. And I have it as a desktop app. You can do it in a website if you want. You might like run into issues if you use the web app Postman of like you need to like require cores or whatever. If you're getting that error, just look it up on Stack Overflow. It's like kind of an annoying thing, but if you do it in your desktop or like you have it downloaded, you're not going to really get that error that often. So right here we have a server, and nothing's really returning because we haven't set up like the server's running, because essentially if the server wasn't running, then in this instance, like we killed the server by saying option C. If we try and like sending a GET request, it'll just be like, can't send a request because there's no server running. But if we run our server and we go to Postman and we're saying we want to GET request from localhost 3000, it's just saying, okay, we're returning some HTML, but like we can't use GET because there's no endpoint that we defined that has like any GET. Yeah, question?
Yeah, so what exactly is the bar makes this a server, makes this act like this server?
Yeah, so right here is where we're like importing Express, and then application is actually the server. So app is the server that we're building. Yeah, Express returns to you. Essentially, you're initializing an application by calling this Express function. So Express is just a library that's used for like building backend applications and like servers. And if you call this function, that's what initializes your server. And then to actually set it to some port on your localhost, you have to say app.listen. All of this other stuff is actually unnecessary for the time being. But yeah, that's we'll get to that in a second. Okay. Cool. Any other questions for right now? Okay, awesome. Okay. So we did this last time where we kind of like defined some API, or we created some server, we made some API. So for instance, last time we had something along the lines of like, we had like app.get, we had like a // and then we said we had some callback function. You guys don't have to follow this along. This is just a demo of like a recap of last time. We had some request, some response, and then we said, you know, res.send. So this is an example of what we did last time. We created like our first endpoint, which was just the // And again, the / is literally like when you go to some website. So you go to like meta.com. Your browser automatically adds in a /. So if you're setting some route to a /, you're basically just saying what's like the default router. And the default router is this /. So if we started our server. Also important thing to note is that let's say I'm starting a server and then I want to change something. So I want to say like some GET request. Even if I save it, I have to then kill my server and rerun it in order to see the changes. So right here, if I deleted it, I save it, it's not going to change on my server. So I have to kill my server and rerun it. That's just a side note in case you're getting any errors or like not seeing why something's populating. So I'm running this server. If I go to my Postman, I get /. I can see that it returns hello world, which is what I expected because I just created that endpoint. So I'm not sending any request to the server, but I'm saying I'm expecting some response. And so when I tap into that endpoint in the server, the API is telling me that once I go to this GET request, which is this like home page on my local host, then it's going to return some response, which is saying hello world. But none of this is really interesting because like when you're working in the backend, you're not actually like looking at anything. You just kind of want it to store information or get information, which is exactly what we're going to be doing right now. And we're going to create our first database. So let's kill the server. Let's clear this. And now we're going to do some setup. So this might take a minute. So let me copy this over. Okay, so if you have a Mac, go through these steps. I'll go through them with you because I have a Mac. If you have a Windows though, or like a Linux or like another operating system, go to this link here and follow the steps to download MongoDB. Because right now we're going to download MongoDB, allow it to run on our computer, and then we're going to start creating databases. So if you go to like this link, it'll say install on Linux, install on Mac OS, install on Windows. I'm not going to do any of that because I already have it installed, but I'm going to go to, I'm going to go here and open up your terminal. And then the first command you're going to run is brew tap mongodb/brew. I'll just do it, whatever. Okay. Next, we're going to run this command. MongoDB-community. Okay, cool. I already have it installed. It might take a little bit to install for y'all. And then I'm gonna run this last command. It's probably gonna tell me that I already have it. But okay, yeah, it's telling me I already have it. Cool. So I'm gonna clear this. I'm gonna give it like another minute for y'all to run this command. The use database tutorial. Sorry, is this what? Is that also don't run it just yet, because essentially what we're gonna do. Let me close this. Okay, I'm gonna move on to the next step. Just if it's still downloading, I have it like the commands commented out here. But essentially, in your terminal, type in Mongo. This is gonna open up the MongoDB like shell. So if you guys have ever worked in Python before and you're like in your terminal, you just write like Python, it'll open up like a Python shell. This is exactly the same thing that's going on with MongoDB. So if you type in Mongo, it's going to open up some like Mongo shell. And then I'm going to say, because I already have a database tutorial, I'm going to say database let's just call it database intro actually. So I'm going to say use database intro. So essentially what this is doing is I'm creating a database in MongoDB. So I'm in the Mongo shell right now, and this is interacting with the MongoDB server. And I'm saying, create me a new database called database intro. And now I can switch out of it. So I'm going to say npm install mongoose. That's safe. So this is downloading like some dependencies and that are going to be important in MongoDB. Okay, cool. I'll give you all another minute just to go through that. And then we'll actually create our server. Yeah. Yeah, I would install Homebrew and then go through the setup. Homebrew, yeah, install Homebrew. I think, wait, there should be. Yeah, I probably should have mentioned this before, but if you don't have Homebrew, usually like most of y'all have Homebrew, but if you don't, just go to Homebrew's webpage, copy this for your Mac OS terminal, and then you should just run through the commands again. I'll leave them up. So if you want me to scroll up and like see commands, anytime in the lecture, just let me know. Okay. So it's fine. Okay. Okay, so let's build our first database. So what we're going to do is say Mongoose is essentially some library that we're going to use in MongoDB. That's like just important when you're like interacting with websites. Again, it's some library that we have to import. So we're going to say const mongoose require mongoose, and then we're going to say the URL of our database is going to be MongoDB : // and then just make sure you guys type in this correctly. It's essentially an IP address to where our database is stored in like the MongoDB servers. So I'm just going to copy it from here. And then make sure this after the / is whatever you named your database. So my database was called database-intro because I just created it in the Mongo shell. And then I'm gonna save this. So that's what it looks like. Okay, cool. Next step, this is all just like setup. We're gonna connect our URL. So basically what this is doing, it's the equivalent of like initializing our application, but just for the database. So we're saying DB, we're creating some connection to like the Mongoose library, the same way we did with Express. And then copy these two commands down. You're gonna have to do this every single time you create like some database, and essentially, oops. What this is doing is opening up your database, creating a connection with that database when it's stored somewhere in the cloud in the MongoDB servers, and just like authenticating and making sure that yes, your database is stored there. And yes, there is a secure connection to it. And you can start manipulating it and working with that database stored somewhere in MongoDB servers. So what these two functions are saying, so we're saying database, it's a one-time listener that basically is to open your database and make sure that you do have a connection with your database. So if the connection is successful, it'll say console.log database connected. But if you have some error, we're basically listening into like some error. You guys can think of this kind of like as an event listener with buttons or whatnot. If you're listening for some error and some error returns, we're going to console.log that we have some connection error, which is what we're going to tell our user to let them know that something's not working and you need to fix it. So let's test all this out. Let's go into our terminal. Make sure that my server is there. It is. So I'm going to say node server.js. Cool. So we see two things. They're important pieces of information. And the first one tells us that we have an example app listening. So we started some server and it's listening on localhost 3000. And we connected our database at this basically endpoint, some MongoDB website, some IP address. And then we're saying that our database is called database intro. And it knows it's us because we're like, it taps into our client and basically says, we know who you are. You have like some unique ID that's basically, connected in the MongoDB servers. And it's saying only you have this like database intro. That's why we don't have the same database because MongoDB understands that every user is unique. So they're going to make that database just for us whenever we tap into their servers. Okay, cool. Let's kill the server. So now we have everything set up and we're about to start programming our API and creating our database. So the first thing we're going to do is create our model. So an instance of a model is called a document. And essentially, we're going to define what our database is going to look like. So what are the entries in our database going to look like? And how are the items going to be organized inside of our database? So the database that we're going to create today is a to-do list. So we're going to have a few things inside of a to-do list. You might think of what you want in a database that's storing to-dos. Maybe you want a to-do list and you want every item to have like some title, maybe like more specific data, like some description, maybe like, how urgent is this like data? Is it like, or how urgent is this to do? Is it like really important? Do I need to do it right now? Or can it wait a little bit? And maybe like some date correlated to like when we created it. So we're gonna create this. So the first thing we're gonna do is create something called a schema. So essentially, a schema is a JSON object that defines the structure and the contents of our data. So let's create some variable schema. Oops. And we're going to initialize this by going to the Mongoose library. And we're going to say return some schema. And then we're going to say the item that we want to be included inside of our schema, essentially what we're expecting out of our data in our database. is going to have these properties. So we're going to say every item has some title, and we're expecting a string to be returned. Every item has some task, which also we're expecting a string to be correlated with that, essentially like object inside of the JSON object that we're creating inside of our database. Some date, which is also some string, and some urgency. And let's just say that we're expecting some number. So maybe like, let's just say like 1 is not that urgent, but 3 is urgent. So maybe like 3 is like super urgent, like super high priority, and 1 is like low priority. Yeah, question? Date, you're right. Thank you for that catch. Any other questions? Yeah. Yeah, I imported Mongoose. Yeah, which is essentially like a library that we're going to use to communicate with MongoDB. Okay, cool. So after this, we're actually going to create some database, and we're going to call it to do. So what we're doing here is, let me copy this in. So what we're doing here is we're creating some database, and we're calling it to do. Or really, it's not a database. It's actually like a model or like a document. And inside of this document, we're expecting that every object that's stored inside of our document looks like item. So we're expecting that if we open up kind of like our document, which is stored inside of our database, you can kind of think of our database as like a bunch of different documents. So, if we have like one big database, which is DB, this could be like one document, which is our to-do. We can have like another document, which is like maybe like grocery, whatnot. But essentially in non-relational databases or NoSQL databases, this is how your documents are organized. We kind of call it like horizontally because these documents aren't related, but we can create as many as we want. And we're defining every specific document under certain constraints. So we want this to do to only have items in it that look like item. And we want maybe grocery to have a different set of objects that are stored into this document. So every document we constrain by setting it to like map according to some model that we created. And we know that for our to-do, we're modeling it around item, which is a schema that we created that essentially contains these 4 parameters: title, task, date, and urgency. And so from this, we're going to basically add things to our database, add items to our database that all follow kind of like these parameter guidelines. Not really guidelines, they're actually strict guidelines, they're enforced, but that's what we have to like, if we want to put something in our database, this is what our database is expecting. Okay, cool. So let's talk about CURD operations for MongoDB and Express. So CURD operations are operations that we use to work with our database. So CURD is an acronym. It stands for create, update, D is delete, and R is retrieve. So these 4 operations essentially make up what we're going to be doing to communicate with our database. So you can imagine we want to like create things in there. So this is synonymous to a post. We want to update things, which is synonymous to a put. We want to retrieve things, which is synonymous to an HTTP GET. And we want to delete things, which is just delete in HTTP. So we're going to create all these operations. We're going to create an API to go along with them. So let's start with create. So we're going to introduce the router, which is something I was talking about. Let me actually just copy this in, and then as you guys are copying it down, I'll start explaining everything, so I don't have to explain it and like also talk at the same time. Okay. So essentially, I talked about React and how we have different routers. We have different routers in React that navigate you to different pages. So you can think of a router when you're using, when you're working with servers or with APIs as navigating you to different endpoints. So a reason why a router is useful is because if you guys remember last time we had like app.get, and then if we wanted to like, we'd say, let's say like we wanted to call like hello, and then we have to do like, response. We're making some like callback function. We have to then, write a callback function. And then if we want to do another get request, we have to copy this down and say hello. But what if we have like one endpoint, which we're doing a bunch of stuff, right? So last time I talked about, if we have like, let's say we're expecting some ID to be put into this get request. And if you remember from last time, this syntax is basically saying, like, if I'm calling localhost 3000 / and then I type in a bunch of numbers or whatever, it can be numbers, it can be symbols, letters. Essentially, this colon is saying anything after the / we're expecting to just be some ID number. I showed you how to essentially retrieve, or theoretically, how we could retrieve some ID by saying, / some ID. If we had maybe like, test / / test / ID. When we make a request to our API, we have to say like test, whatever. But what if we also, instead of just getting some ID, we also want to like post some ID, and essentially create the exact same thing. But instead of just having a get, we want to do a post. Maybe we also want to do like a put because we're posting. So we want to like update something in the database. Maybe we want to do like a delete. It's kind of annoying to have to like write out every single one of these and make it to the same endpoint. It looks kind of messy because, let's say like in between here, we're like doing another app.get. And we want to get like something else, which is like / hello. And then we have, oops, let me just, like you guys can see how this can get pretty messy and pretty ugly. So what we actually use to mitigate all this like ugliness is use something called a router. So a router we defined all the way up here. We went to the Express library. We told it to return us some router. And then we're saying app.use at / this router. So what we're telling our server is, or our API, is basically saying that for our application, which is our server, anything that comes after /, we're going to just don't use any of the endpoints that we define ourselves. Any endpoints that have our website, localhost, and then the / just default to the router's routes. So we're going to define all the routes using our router. And why this is really useful is because of what I just explained. We don't have to group together a bunch of gets and puts and deletes. We can literally just use like one endpoint and do a whole bunch of things on it. So we can define one endpoint, maybe even call like several get requests if you want. Put a get, a put, a post. Might not make 100% sense right now, but I'll explain why it's cool in just a second. Anyway, so I hope there's enough time to copy this chunk of code down. If it's not, and you guys are already like kind of behind, just like tune in. This will all be on the recording later, so you guys can like look at it when you're going through your final project. But anyway, what we just defined here is we said, so we're tapping into the first operation in our current operations, which is create. We know it's create because I just told you we're doing router.post. Post creates something, it's an HTTP post request. And what we're telling our database is we're creating some new entry inside of our database. So if we're going to create something, we're going to say router.post, and we're going to tap into database. So if someone says localhost, let's just say so if someone does DB, our router is essentially saying, okay, we're listening for this endpoint. Now, if someone goes to this endpoint, we're going to do something. So the thing that we're going to do is called is callback response, which essentially, again, callback response is called back after something has been done. So when we tap into the server and we connect with it and we say we were looking for a post request, it's like, all right, sounds good. We're listening for this like request and we're going to send this response, and this fulfills this callback function. And in this callback function, after we submit that we want some post requests to happen, we're going to create a new to-do. So I'm going to say const to-do is a new to-do. So we use this syntax is basically saying to-do is like our schema that we created. And we're going to create some new to-do item that follows this schema to do. So we're saying, you know, it's basically an object. You can think of it as like a database object. And inside of it, we have some JSON. So essentially what the user is going to do is pass in some title, some task, some date, and some urgency. We're going to pull all of this information the same way we did last time by saying inside of this request, we know that it has some body and some title in it. Inside of the task, we know there's like some body and some task. Inside of date, we know there's a body and a date. Inside the urgency, blah, blah, blah. After we create this new to-do, what we're going to do is actually save our new to-do inside of our database by calling to-do.save. So we're saving it inside of our database, and we're creating a callback function, which is going to anticipate either an error or some document. And if we get an error, we're going to return the status of failure. But if not, we're going to return that essentially that we have some success, some ID that's automatically created when we put new elements into our database, and the content of what we just passed into it. So, okay, we just created our first function and we initialize our database, we initialize our server. Now we're actually going to look at what this does. So if I open up my terminal and I run this. Okay, cool. So we have listening at localhost. So I'm going to copy this, and we have our database is connected. So cool. We have our server running. We have our database running. So I'm going to go into Postman, and I'm going to say, okay, we just created some post request. So I'm going to go into post. What do we call this post request? Okay, we have the endpoint DB. So I'm going to say, I'm going to create a post request to an endpoint that's called DB. I'm going to go into the body. And because it's a post request, I have to pass in something. So let's create some new, I have to pass in a JSON object into this post request. So we defined what our schema is expecting out of new items. So it's expecting to follow the to-do schema, which is a title, task, date, and urgency. So let's say we have some title, and then let's name this title homework. So we need to do like some homework. The next thing is task. So I'm going to say, okay, I have some task. What is that task? It's CS 189 homework. So maybe like a bit more in depth of like what that task is. Let's just call it CS 189. I have another parameter, which is dates. So today is March 9th. So, or sorry, March 29th. So I'm going to say March 29th. And my last thing is urgency. Oops. Yep. But you have to be careful here. We can't pass in a string because as we defined in our schema, we're anticipating a number. So when we're calling our post request, we have to make sure that we're passing in some urgency. That's a number. Because it's like maybe let's say this CS189 homework was created today. I'm like, okay, it's not that urgent. It's not due tomorrow. It's maybe due in a week. Let's just give it like some arbitrary value of 1. Okay, cool. So then when we send this post request, we're going to see, okay, status success. Our database automatically created some ID for us that specifically relates to this to-do item. And we have the content of our item, which we expected, because if I close this, we expected that on save, when we're storing it inside of our database, there was no error. So we went into the response.json and we're returning some status saying success, some ID, which is the automatic ID that's created for this to do. And we're saying have some content, just return the request.body. So the body of this request is what we just wrote right here. So it's saying, okay, we have some content, and this is what we passed into the request. So we have title homework, CS189, March 29th, urgency is 1. So we're like, okay, yeah, that's pretty cool. We just created our first item in our database. Are there any questions on anything right now? Okay, cool. So this is pretty exciting stuff. Let me open this. Oops. Okay. This is pretty exciting stuff. We just created something in our database, but we can't even see it yet because we wrote no get requests. If you look up here, we just initialized some server. We made some API. We initialized some database, and we just called a post request, but we want to retrieve some information, which is the second acronym we're going to talk about in this like CURD operations, which is retrieve. So I'm going to copy this bit of code. And as you are maybe copying it down, I'm just going to explain it real quick. So again, we're using our router to route our endpoints. So we're saying route, we're expecting some get request. And this get request is going to be db/all. And what all is doing is it's going into our database, which we defined as to do. So if you look right here, our database or our document rather, which is called to do, we're gonna look inside of to do and then find essentially all items inside of to do. So this is a built-in function inside of Mongoose, which is why Mongoose is so useful. You can use functions like this. So we're saying inside of this document, find any and all essentially entries or JSON objects that we stored, that follow like our schema. And then we're creating some promise and we're returning some to-dos. So essentially, after it finds all of the JSON objects that are stored inside of our document, we're then going to call this callback function, which is accepting all the to-dos, which are all the JSON objects, which is in our document. And we're going to return a message that's saying return all to-dos. And we're going to create some parameter to-dos and return all the to-dos that are passed inside of our callback function. So let's see what this looks like in action. I'll look at my terminal. I'm going to rerun my server. Okay, great. My server's running, my database is running. Let's open up Postman. Okay, we had some post requests. Let's switch to get. And then we created some endpoint that's db/all. Cool. So if I look up here, we have some message which is saying return all to-dos, which we expected because in this like JSON, we're saying return all to-dos, comma, another parameter, and we're creating something called to-dos, and we're going to return all the to-dos that we found using our find function. So you go in here and it's saying return all of our to-dos. We have some to-dos, and as you can see, this was the ID that was created with that to-do. We have a title homework, CS 189. The date is today, and the urgency is 1. This V, I think it's like version or something if you have like identical copies of the same like entry. I'm not really sure what that V is, but it's not that important. But the important thing is basically all of these entries and the ID. Okay, cool. So we're now 2 steps into our current model. We're 2 steps away from building a fully functional database. And we still have 2 things yet to tackle. And those 2 things are deleting and updating the data that's already inside. Because right now we can create new items inside of our to-do list, and we can see all of the items, but we can't delete them or update them. And also one other question is if we're trying to get some specific ID, maybe we don't want like a list of all the IDs. Let's say we have like thousands of entries and we just want one of those items. How do we make it so that we can just retrieve one of those items and not the entire list? We're using this find, but is there like a find by ID type of function? We'll look at that right now. So this next section is called Intro to Routers. And we're going to see the real beauty of routers. So again, I'm gonna copy this code in and explain it. So intro to routers, I explained a bit of what routers already do. They essentially navigate your endpoint to like a specific location. So now we're creating a new endpoint, and we're gonna call this endpoint /db/ID. So this is essentially saying if we have some, we have like some, right now we have db all, and right now, instead of getting all of them, we're gonna expect something, which is just like some ID. So we're using this syntax, which is saying match everything on this side to just something that we're gonna call ID. And what we're doing with this ID is we're gonna call a get request. And we're saying we're creating a callback function, and we're saying, by the way, if you weren't doing this with a router, this get request would look something like .get, and then you would have to specify the endpoint. But that's the beauty of routers, is that I don't have to specify the endpoint. I already know the endpoint because I defined it with this route. So I'm just I'm creating a get request for that specific route. So I'm saying, in this get request, we're going to find a certain item from the database. And to do that, we're going to go into our document to do, which is over there. And we're going to find by ID. We're going to get the ID from the request parameters. So you can imagine if someone sends something to our database that's like 6, 7, 8, 5, 2, 3. That's going to be our ID for whatever we're trying to find in our database. So we're going to look through our document, find this ID, and the way we find that ID is we're going to pass in the ID that we're getting from our request, and then we're creating a callback function, which is saying, okay, great, we're going to fulfill this function with basically an error and a to-do. And if we error, we're going to just say failure. So if anything goes wrong in trying to find this element or like this ID, let's say this like ID doesn't exist, then it's going to return some error that's saying we have a status failure. But if it doesn't error, we're going to respond with that specific to-do that we found that correlates to that ID. So let's look at how this works. Let's open our terminal. Rerun on a server. Okay. Awesome. Everything works. Let's go in here. Let's take this ID and let's stick it in the end. And perfect. We're returned this exact element because we looked through our document for this ID number and we found it. and it returns exactly that element that correlates with that ID. If we were like a couple letters off, let's just say like that, we're going to get a status failure because there's no ID that correlates to something in that database. So we caught an error, and essentially we're just displaying a failure. Okay, so that's a router. But let's add some interesting stuff to this endpoint using the cool features that I just introduced with routers. So the next step of our current model in our operations is update. So let me paste this in. If I was writing this, it would take me a long time. Okay, so this is exactly the same code we have up here, except this is the beauty of a router. I don't have to say db id dot put. Instead, I can just use this cool syntax of basically saying at the end of get, I'm going to do like a dot put. And I'm essentially saying at this endpoint, I can also do some put HTTP request. Another note real quick is that you can't put a semicolon like that, or you're going to get like a weird kind of error. It's just something to keep in mind. I always like ran into errors with this kind of stuff. Now at the end of this, I'm saying, okay, I know we can do a get request using the ID, but let's actually put a put request. So puts are used for updating information that's already there. So what we're going to do is, let's say we have like some, some item that's like in our database, and let's say like a day has passed. And let's say that we programmed into our website that every day that something passes, the urgency increases by 1. So today it's 1, but maybe tomorrow it's 2 or something. So we're going to say automatically, when the day changes, go into our backend, go into our database, and find that item and increase that urgency by 1 or something. So what this put request is doing is, again, we're creating a callback function, request response. We're going into our document. We're going to say find by ID and update. There's a couple find by ID functions. There's find by ID and update. There's find by ID and delete, which we're going to see in just a second. And into this function, we're going to pass in the ID that we're trying to find, a body, which actually we're passing into the request, because when we're making a put request, we want to change the information that we're going to want to pass in the information that we want to change, and then creating another callback function, which is doing the same thing here, which is saying if we find some error in this whole process, return some failure. But if not, let's return the to-do that we found and that we just updated. So very cool. Let's go back into our terminal, rerun our server. Great, everything runs perfect. Go into this, and just for fun, let's create another item just to mess around with. So how do I create an item? I had some posts, so /db, and I passed in some data into it. So let's say /db body. Let's say maybe I want another class, like 100 or something. And maybe this was like yesterday. So I'm saying March 28th. I'm setting the urgency to 2. Cool. It says success. If I look at all of my entries in my database, oops. Not post, get. If I look at all the entries in my database, I'm going to see I have this homework for CS189 and another homework for data 100. Like, okay, cool. So now let's update this information. So let's get this CS189 homework. Let's get the CS189 homework. Maybe it's due tomorrow, and I'm like actually stressing about it now. So instead of setting the urgency to 1, let's change it to something else. So I'm going to go into my database. I'm going to find that ID number, and now I'm going to do a put. When I do a put, I have to pass in new information that I want that ID to look like, or that element to look like. So I'm going to say CS189. This was March 29th that the thing was created, but the urgency, let's set it to 3 because I'm pretty stressed out about this assignment. I'm like, oh, I need to get this done right now. So let's send this put request, and boom, no failure was sent to us. It's sent back the to-do that was found, which is exactly what we wanted it to do. So now let's look at our database. So if we go to db/all, which is the endpoint to find all the items in our database, we're going to look at this GET request, and it's going to return to us all of our to-dos. And as you can see, the CS189 homework, we changed the urgency to 3, which is 75% of the way done to fulfilling all the CURD operations and making our database completely functional. So cool. We're this far into the database development. Are there any questions before we get into the last step? Okay. Now, nothing's new here. The last step is literally just as easy as all the previous steps. And what we're going to be doing is defining the delete function. So let me open this up. I'm going to copy all the code we had before, but also just add in some delete route. And so we have the get from this endpoint. We have the put from that same endpoint. And now we're creating a delete. And the delete is very easy. Exactly the same thing as the other ones, except we're saying to do, find by ID and delete. We're passing in the ID. And there's no body that needs to be passed into a delete function because we're not changing anything. We're just deleting some item. We just need to pass in the ID of whatever we want to delete. We have, again, some error. So if there's basically, if we catch any errors in this whole process, we're going to expect that. And if it's passed in, we're going to say, okay, if we have some error, we're going to return failure. If we don't, we're going to return success. Okay, this all looks good. Let's open up our terminal. Okay, awesome. Server's running, database is running. Let's go back into Postman. We have all these items in here. We're like, great, sounds good. But thankfully, I just finished my 189 homework. I'm like, I'm not stressing anymore. I'll stress about that again next week, but for now I can just let it chill. So I'm saying, okay, let's just make sure that that's the exact item we are trying to look for. So if I call a GET request on that ID, it's going to return to me exactly what I want. So I'm like, okay, cool. Now I don't want this. I just finished this, so I want to delete it away from my database. So I'm going to say delete on the database / the ID. If I create this delete request, it's going to say success. I'm like, yay, finally, I got this out of my database. I don't like it anymore. If I'm trying to get that ID, it's going to say null because I deleted it from my database. So let's look at all my items in my database. And now I only have my data 100 homework. And all 4 steps of the CURD are fulfilled. And my database is complete. I can create things to my database. I can get them. I can update things, and I can delete things. Yeah, backend stuff. It's pretty cool. And in your final projects, I hope you guys find it interesting. And let's go back to this. Okay, so that was basically it for backend. Before we end today, just a few announcements. So homework 5, the NASA API is extended until April 1st. The full stack social media platform is due April 7th. We have final project introductions on Thursday. This is like the most exciting thing. A bit of personal advice for everyone. I took this class last semester, and I had a bunch of homework assignments leading into the final project. I know that's definitely like, I know that a lot of you guys definitely still have assignments that are like still out there or that you haven't completed. I would honestly just say, read through them as fast as possible, or just like try and get as much done. And just don't worry about any of the assignments, and just this weekend, commit to the final project. I promise you all the learning that you're going to be doing is like culminated into this final project. It's super, super exciting. You get to work with the team, like actually develop a full idea. Like you guys might have like some ideas about like a game or like an application or a website, and literally you have the tools to build it. So you're going to be given mentors, a team, and y'all are going to work together to design an application, do the front end for an application, and do the back end for the application. So start thinking about ideas now. Start thinking about like maybe what role you want to fit into the team. If you want to work more front end, more design, we're going to have design lectures next week. We're going to have like 3, I think, UI UX lectures. So that's going to be really exciting. We're going to teach you guys like Figma and stuff. So that's really awesome. Fill out the group preference form on Piazza if you have friends you want to work with. And we have a decal social actually Thursday before lecture. So we're going to be doing like, I don't know, some kind of like speed dating, like everyone just like hang out, talk to us about stuff, meet your mentors. And then the attendance like grades, I guess, were also sent out over spring break. So essentially, if you guys are coming to most lectures, you're pretty good, but like we sent it out to people who have come to like 0 or like only like 1 or 2 lectures. Yeah. Also, if you like are posting on Piazza that you like can't make it to like some lecture or whatever, again, we understand we like accommodate everyone. We just want everyone to learn as much as possible. But those are the announcements for this week. I'm going to be releasing the okay, wait, let's end this meeting.